Hi, everyone. Oh, okay, yeah, that is as bright as it was in the other room. And I cannot see any of you and your expressions except for like the first row. So yeah, good afternoon. Thank you so much for, coming here and joining me this afternoon. And thank you so much for FITC for bringing me to Toronto. Like, it's a really beautiful city, so thank you so much. My name is Shirley, and I'm an independent creator of data visualizations. I started out my career back in 2012 as a software engineer at a big data company, and that's also where I first learned D3 and how to create data visualizations on the web. And I love that so much that in 2014, I ended up taking my second role as a front-end developer for a data visualization product. And in 2016, I decided to quit my full-time job and go all in and take the leap and start doing freelance specifically for data visualization projects on the web. And then the last 3 years, I've had the incredible pleasure of working with different clients across a variety of industries, mostly across the tech, media, and journalism industries, as well as on a personal project with my really great friend, Nadi Bremer, where we chose 12 different topics and created data visualizations around those topics and wrote about our whole process from start to end. So today, I want to share with you some of those past projects, but more importantly, I want to share with you the lessons that I learned throughout the whole process of the data and design and code. So let's get started. First, the very first thing of any data visualization project is, of course, the data. And I've learned over the years that when I start on a project for myself, that I don't actually start with a particular data set. And instead, what I do is I start out with a curiosity. Because I found that as long as I have a curiosity about something in this world, that curiosity will motivate me throughout my project, especially when things get hard. And as long as I have that curiosity, I found that I can go and get very creative with my data gathering process and find the data sets I need to help satisfy and answer that curiosity. So in the summer of 2016, I was extremely obsessed with this one musical called Hamilton. I don't know how many people have heard it, and even if you have, and raise your hand, I can't see you, I'm sorry. But I was so obsessed that I had it on repeat for like 3 months straight, and my husband was like, why don't you just make like a data visualization of it or something? And I was like, no. And then I was like, okay. So this is an interactive visualization of every line in Hamilton, where as I scroll down the screen, the dots kind of come apart and burst apart and come together, and each of these dots represent a set of consecutive lines that a character sung in the musical. And as I keep scrolling down, I present to the reader the analysis that I did and the interesting patterns and insights that I found in the musicals until they get to the very end, where I present my reader with the visual tool, the filter that I used to do my own analysis, where they can filter by any set of characters, conversations, and themes, and dig into the remaining lines to do their own analysis. This project really started because I had two primary questions, two primary curiosities. The first being, how do the relationships between these characters change as the musical progresses? And the second being, what recurring phrases, what recurring themes are there, and who are they associated with in the musical? And as you can probably imagine, there was no such data set out there to help satisfy this curiosity. There's nowhere online that I could have possibly found it. So I went and manually went through all of the lyrics the first time around, writing down and noting and putting little like post-it notes on any recurring phrases I found. Then once I was done, I grouped them into broad general themes. And then I manually went through the lyrics a second time so that I can enter all of those recurring phrases and themes into my computer, along with all of the characters and conversations. And then I aggregated all of that metadata by song and line number. I wrote a script to do this to get my final data set. And this project and many, many others like this have really taught me that as long as I have a curiosity, then I can really get any data set out there, whether it's by manual data entry or with APIs or automated scripts with like Node.js, or I have friends that use like R packages. As long as you get creative, there's some sort of a data set out there, as long as I stay within the bounds of the law. Yeah, I don't want to do any illegal things. So once we have our data, we want to then get on to our design. And one of the most important things I learned is to really make sure to explore our data that we just got before starting on that design. So this is one of my favorite personal projects called 4 Years of Vacations in 20,000 Colors. It was one of my personal projects for data sketches, where I took 4,000 images over 13 different personal trips and extracted the top 5 colors from each of those images. I grouped those colors by the trips that they were taken on, and I arranged them by the day that they were taken on. And this is one of my favorite personal projects because I feel like I learned about myself so much from this project, more than any other project I've done, which is that I've always known that when I travel, I really like taking pictures of nature. And so all of the blues and greens really make a lot of sense. Because I like taking pictures of like mountains and lakes and oceans and forests. But when I first did this project, I was really confused as to why I had all of these reds and yellows and purples. And so when I took a look at the underlying data set, the underlying photos, I learned that they were all food pictures. So this 2014 trip to Japan, apparently all we did was eat. Yeah, and so was this one in New York. Yeah, one of my personal favorite projects. But when I actually started on this project, it actually didn't start out that well. And what I mean by this is my very first kind of sketch, like a little idea. I jotted down right after I had gathered and cleaned all of my data. And I had really good intentions, which was that I wanted to figure out where and when I was taking my photos. And so you can see, like, I jotted down this whole, like, weird, like, okay, x-axis is going to be, like, the time of day. And then also right by it, it's going to be, like, the continents I took the pictures in. And the y-axis was going to be the year that I took those pictures. And it just kind of sketched out some ideas that I thought might be interesting. The problem was, though, that I hadn't taken a look at the data at all after I gathered it. I didn't try to explore it. I didn't try to understand it. And so what happened was, this is what happened when I plugged the data into my code, according to how I sketched it out. Yeah, so this is now one of my favorite pieces. I like to tell everyone. It is a postmodern art piece, and I call it Man Peeing into Puddle. Imagine that one day it's gonna, sell a lot. But I'm just kidding. But back then I was like, this is not a Data Vis piece, so I need to take a step back. So I took a step back, and I really asked myself, what metadata do I have? What metadata does each photo, each of my data points have? And I realized that I have the trip that that photo was taken on. So I decided to group all of those colors by that trip. I have the information of the day and time that that photo was taken on, and so I decided to map that to the angle so that it would go around the circle. And finally, because they are colors, I have hue, saturation, and lightness information. And so I decided to map the hue to my radius so that it would go in a gradient from orange to yellow to green to blue to back to red. And that's how I got the final visualization that you saw earlier. And so this project really taught me the importance of exploring my data before I start to ideate and sketch and prototype and design, and to really list out my data attributes so that I can assign the quantitative data attributes like XY positions, the quantitative data attributes to the right visual channels like XY positions, width, height, radius, and the categorical data attributes to visual channels like color and shape. And to make sure to watch out for any extremes in the data and to account for any outliers. But over the years, I've also found that creating compelling data visualizations take more than just assigning the right data attributes to the right visual channels. And I've found that some of the best visualizations I've seen have a masterful use of visual metaphors. Like when the New York Times decided to visualize upward social mobility literally as dots animating up the screen, or any number of articles that have decided to use red bars dripping down to signify a data set about deaths or murders. And I firmly believe that it is this subtle use of visual metaphors that help our readers kind of clue into what the underlying data set might be and reduce the barrier of entry to understanding for them when they come across a new exotic visualization. And in a world where our readers are constantly bombarded by thousands of different things vying for their attention on their screen, I found that it's important to design to maximize for their delight, to give them little things, little attentions to detail, little flashy details even, that will motivate them to keep engaging with the story and to keep scrolling through the story. This is a project that I worked on in fall 2017 with my really great friend Nadia Bremer, as well as the Guardian US team, called Bust Out. And it was an article about the homeless relocation programs across American cities. And to do this project, the Guardian US team took a year and a half to get data from 16 different American cities. And they were able to obtain more than 20,000 data points of homeless people's journeys across the US. And it was a really incredible piece of investigative journalism where they looked into the different cities and the bus tickets that they were buying, as well as the plane tickets and their starting and ending destinations for these people, the different income levels for each of the cities that this was happening in, and even the acquaintances and the friends and family that received the homeless people on the other side, as well as potential motivations for this program, like how in San Francisco, over the course of 10 years, more than 10,000 people have received bus tickets to go to another city, and that without this program, San Francisco would be double the population. So Nadia and I worked on 5 different visualizations for this piece, but today I want to concentrate on just one of them, and it's the one for New York. New York was a very unique city in that it's the only American city that not only bought bus tickets for their homeless people, but also plane tickets. And so we, along with the journalists, we wanted to do two specific things. First, to highlight the furthest flights that New York had bought for their homeless. And second, to show the most frequent destinations for their homeless people. So to accomplish the very first goal of highlighting the furthest flights, the very first thing we thought of was a map. But we didn't want to use a map not only because we had just used a map to start and introduce the project, the data set at the very beginning of the article, but we didn't want to use a map because maps are inherently just really bad at comparing relative distances between different starting and ending places, ending points. And so the second thought is a bar chart, because bar charts are made for comparing relative differences between different quantitative values. But we wanted to give our readers something a little bit more visually engaging. And so we came up with this visual metaphor of a flight taking off from one end of the screen and flying across the screen in an arc and landing on the other side. And it was really straightforward from there to expand the visual metaphor to account also for our second goal of showing the most frequent destinations, because we could then show people as dots that followed the flights across the screen. But even then, it took many, many, many iterations, this just being a few of them, to get the animation to a satisfying point where we felt like it would engage the reader and motivate them to keep scrolling through the story without really bogging them down in too much animation. And so this is the final visual for New York, where each arc is a flight taking off and landing at their destination, and each dot increases as more and more people arrive there. So far, we've talked a lot about the data and the design, but now I want to talk about the code, which I think is what we're all really good at. So to draw data visualizations, to create data visualizations in the web, we need to be able to draw shapes through the browser. And I like to joke around that Data Vis is basically just SVG and trigonometry, and that's all that is, but it's a little bit true. And one of the best things that I think I did for myself is to teach myself SVG paths, and in particular, all of the curve commands that SVG paths have, because with that understanding down, I found that I can really, really dream up and draw any shape that I want in the browser. So this is a project called Film Flowers, where I take the top summer blockbusters of the last 2.5 decades and reimagine them as flowers, where each of the different petals are parental guidance ratings, each of the colors are different genres, and the number and size of the petals are IMDb ratings out of 10. And so there's some, I think, really beautiful ones in here, like The Dark Knight Rises or Inception. I always really like Harry Potter. That's just my favorite series. But the one that I always share, that I love sharing, is the 1997 Batman and Robin. It's just so tiny and so cute. I'm like, oh, poor you. I'm sorry. Yeah. But when I first published this project, I got asked, how did I do it? Like, how hard was it? How much time did it take? And the answer was that it actually isn't as complicated as it looks. And what it's relying on is SVG paths, and specifically the cubic Bezier curve command. Okay. So let's go through it together. So I want to draw that cherry blossom shape. And to do that, I start out with a curve on one side. And so the way that I like to think about it is that string, I like to think of it as I start out with a starting point of 0, 0. I draw a straight line down to my ending point, that purple point. I then take the blue and green anchor points, and I nudge them out until I get the point that I want. And that's the cubic Bezier curve command. I then draw 2 straight lines, draw the same curve but on the other end, and copy that petal, basically an SVG path. I make that SVG path 6 more times. I transform and rotate them, add in some color. And so that's how the flowers were made. But just drawing shapes onto a web page doesn't make for a data visualization either. And so for us to make data visualizations, we need some way to be able to translate the raw data, our raw data, into screen space. And while I think that, and to do that, we need JavaScript libraries to help us. And while I think that D3 is the JavaScript library for creating data visualizations on the web, I actually think that there are subsets of D3 where other JavaScript libraries do a better job. And for the last few years, I've experimented with Backbone and React and Vue, and my current absolute favorite is using D3 with Vue and GreenSock for more efficient coding. And I want to show you and hopefully convince you of that with this demo visualization I have. It is a visualization of the blockbusters, of the top 10 blockbusters of the last 10 years. And there's 2 parts to this visualization. First is these 2 histograms at the bottom that show the distribution of Metascores and box office figures. And the second part is this kind of quote, quote, custom part up above that I'm just calling an area chart because I don't know what to call it. But each of these little curves, little areas, represent a movie. And they rise above the baseline when their box office figure is above the median box office. And they droop below the baseline when they make a box office figure that's below the median. And it's inflation adjusted. And I have an additional interaction where I can brush over these histograms and filter all of the visualizations with it. So if, for example, I want to look at any movies that didn't do so well in the box office, but scored really well, then that's WALL-E, it's the Lego Movie, The Martian. And conversely, if I want to see which movies did better than the median, but weren't such great movies, then that's Transformers, and Suicide Squad. So today, I want to code this visualization with you. And this is where I start doing the live code portion of my talk, so please wish me luck. It's probably the last time I'm going to do this because it just is really too nerve-wracking. Anyways, so we're going to start with this. I already have the histogram built out just for the sake of time, and we're going to make the area chart together. And so this is my code, and I have an app.vue, that's my root component. And in here, I load my data, and then I register that data with Vue, telling it that I want to keep track of changes with it. And then I have an area chart component and a histogram component where I pass in that movie's data set. And within the area chart component, I receive the movies dataset as a prop from app.vue, and I tell Vue that I want to watch for any changes on that movies dataset, and if there are changes, then I want to calculate the scales and I want to calculate the data. And what I mean by calculating the scales is that in D3, we use a series of different scales to translate our raw data into what we need on the screen. So, for example, I decided that for my visualization that I want to map my release dates to the x-axis. So let's do that together. First thing I need to do is go and get the minimum and maximum release dates. And so I tell D3 that I have my data set and give me back the min and max for the release date. And then I create an X scale. And I use a D3 scale time. And what that does is it takes in as input a JavaScript date object. And it has an output that is a continuous numerical value. And so what I want to do is I want to have as input 2 months before the minimum release date and 2 months after.
Got min date and min date on the const line.
Thank you for the live debugging. Oh, I love when that happens. Thank you so much. And then I want to map the minimum date to the left side of my visualization and the maximum date to my right side. And so what I'm going to do then is I have a margin object defined up top. I'm going to say margin left, and then I'm going to say the width of my visualization minus margin.right. So my min date to my left and my max date to my right. And then I want to map my box office figure to my y-axis, but I want to also have a baseline that's the median box office figure. So I'm going to use D3 to give me the median for the movies. And then I'm going to go and calculate again minimum box office and maximum box office. Actually, let me just have minimum and maximum box office, pass in my data set and tell it the box office figure for that movie subtracted by the median box office. And then I want to have a Y scale using D3 scale linear. And scale linear, what it does is it has as input a continuous numerical value and as output also a continuous numerical value. So I'm passing in the min and max box, and then I tell it that I want to map my minimum value to the bottom of my visualization. So that would be the height of the visualization minus a little bit of margin, and the maximum box office figure to the top of my visualization, so a little bit of margin there. And then I also want to remember the Y position of my baseline, my median box office figure. And then one more mapping. So I want to map my metascores to some colors. And so I have min and max score, extent, I saw movies. And then I'm going to use d.score, and the color scale is d3.scale sequential, which just means that it's a continuous input and a sort of like a continuous, but an interpolator. And I'm going to pass in as the output an interpolator called interpolate veridis. That's just kind of like a color scale. And pass in as domain my min-max score. And finally, with D3, I'm going to create an area generator with D3 area. And what D3 area does is that if we pass it an array of points, D3 will draw a line, a straight line through all of the points, and then fill everything, the area underneath it, until the baseline. And then I want to tell it, instead of defaulting to a straight line, I just want to default it to this other kind of like more ROM curve. And then I'm going to tell it the baseline that I want, which is the Y position of the median box office. And so now we have all the setup for D3. This was the most complicated part. And then I'm going to say that I want to create an arc for each movie. And so let me remember first, let me just give it an ID. And then for the SVG path string, I'm going to use that area generator that I just created. And because the area generator takes an array of points, the 3 points that we want to draw that curve is starting at the baseline 2 months before the release date, going up to the release date and the box office figure, and back down to the baseline 2 months after the release date. And let's just do that together. So the X position of 2 months before the release date and the baseline, then the X position of the release date, as well as the Y position of the box office figure minus the median box. And then I'm just gonna copy this one back so that it's 2 months after. I'm gonna do the color scale, and then pass in the score, if I've done this correctly.
Under your declaration of area gen, you're calling it as a function?
Oh, thank you so much. You are like one of the most helpful audiences I've had. You are amazing. Thank you for like the live debugging. Good looking out. What's your hourly rate? Yeah, so hopefully now with the live debugging, that it's gonna hopefully work. And so if I've done that, cool. Okay, so I have 98 movies. And for each movie, I have the color and this incredibly long SVG path string. And this is, I owe all of this working on the first try to your live debugging. Thank you. And so now what we have to do is render it. And this is the thing I love about Vue. So I'm going to just say create an SVG path for each arc data that we just made. And then for the key, I'm going to use the d.id. And for the path string, I'm going to do the path that that path string that we just created together. I'm going to fill it with the color and stroke it with just some white so that we can see them overlapping. And the reason why I love using D3 with Vue is that you saw all of that long D3 chain of things. With this one line of Vue, it replaces dozens of lines in D3 that does exactly the same thing. And so I just love it because it makes me so much more efficient. So with just this one line, passing in the data that we prepped, yes, yeah, there we go. Thank you. And now what I want to do with you is code that interaction that I showed earlier, the brushing interaction that maybe looks like it might be really complex, but I want to show you that with D3 and with Vue, it's not as complex as it looks. And so let's get started. Let's now go into my histogram component. And here I have this kind of black box SVG group element that I've given a ref. And on mount, I've created an instance of a D3 brush. And I just use D3 and select that group element, brush element, a group element with the ref brush, and call that D3 brush instance. And in these few lines, what D3 has gone and done for us is create the DOM elements we need and interaction we need to have that brush and that drag interaction. I love this also. But you might notice that none of the filtering is happening because we haven't hooked all of it up yet. And to do that, what we want to do is, on the brush instance, I have these two functions that are called while the brush dragging is happening and on the end of the brush dragging. And so down here, I've defined it. And what I want to do is go and see if d3.selection exists. And what that is this gives us the x positions of the left and right bounds of this brush. So then now what we can do is define our bounds as the x scale that I have, invert, pass in the x position. And what this does is that with D3 scale, not only can I go from the input to the output, so from the raw data to the screen space, I can also do invert and go from my x position back to my raw data. And so, and then I want to pass the bounds back up to my root app component. So I'm going to just tell it the histogram and pass in the bounds. And I'm going to go back up to app.vue, where I have my update filters method, and just make sure that I'm passing up the right thing. I'm going to console log this. And so now, yes, okay, so now I have that I just brushed over a Metascore between 48 and 70, and I can be like this, and I've brushed over box office from these numbers. And now what I gotta do is I'm just gonna go and remember that filter. And then I'm going to filter my original movies data set such that the only ones that are kept, the only movies that are kept are the ones that fit within the bounds of those filters. And so let's see. This is the part I always get really nervous about. Hold on. Okay, so I have my bounds and my filter, and I want to make sure that either there's nothing being filtered, or that that value falls within the bounds. And console.log, this.filtered. And so if I've done this correctly, then when I filter things, then the original data set is 98, but I should see it as less. So yeah, I have 45, 76 movies, etc. And you can also tell that it's working because this histogram is already hooked up and it's happening. And I just want to go and hook this area chart up. And to do that, I'm passing down the filtered data set into my area chart, and I'm going to tell area chart to also look for changes, to watch for changes in the filtered data set, and every time there's changes, just go and recalculate the data, recalculate the arcs that I'm drawing. And down and calculate data, instead of making an arc for every movie, I'm going to make an arc for every filtered movie. And now, there you go. Thank you for the whoa. And one last tiny little detail to finish up. As you might notice, like all of these arcs are just like jumping in, and maybe we want like a nice animation to smooth it out and make it feel better, make it feel more delightful. And the other thing I love about Vue is that animation is a first-class citizen, so it has great integration with Greensock. And all I have to do to make that happen is to have these transition groups and put my SVG paths, my arcs in the transition groups, and it calls these enter and leave functions when the arcs need to be animated in or out. And down here, I have these two functions, and I use Greensock's tween light to say when a arc is supposed to enter, just have it scale up, and then when an arc needs to leave the DOM, just have it scale down. These three things, now, they just nicely animate, which makes me very, very happy. So, thank you, Jason. So the way that I like to think about it is that I use D3, and I use the D3 modules for scales and shapes to translate my raw data into the screen space that I need. And I also use modules like axes and brushes to implement very common data visualization patterns. I think D3 does these better than any other library out there. But I also like to use Vue for their reactivity system to replace D3's enter, update, exit pattern, and also their dispatch system. And finally, I like to use GreenSock, and in particular, Tween with Vue to replace D3's transition, D3's animation module, and GreenSock Timeline for any more complicated multi-step animations I might do. And all of this together have, at least for me, resulted in fewer lines of code and much faster development. So if there's anything that you liked in what you saw or any part of this talk, I have a few more talks that expands on subsets of my talk, like talks about React and D3, and I also have some front-end masters workshops that cover intro to D3 and goes more into detail about the data and design process of building custom data visualization. So if you are interested, and I hope you are, because that's what I'm doing, that's why I do this, but I hope you are, and if you are, then please check out any of these talks and workshops, and that make me very happy. Thank you so much for your time.